All right, everybody, good morning, or good morning for me, good whatever time of day you are in as you watch this wonderful video. All right, so today what we're looking at is we've been looking at quadratic functions. Specifically, we've been focused on our standard form. But if you go back to that quadratic function sheet we did the other day, there was another form called vertex form, and that's what we're going to look at today. So vertex form, you probably tell from the name, it simply is written in a way that shows you the vertex. So our standard form we know is our f of x equals ax squared plus bx plus c, where a and b are just our coefficients, a being our leading coefficient specifically, and c being our constant. On vertex form, we have a times the binomial x minus h squared plus k. In this case, a's are the same, but we actually get a little more information. Our vertex here is going to be at the point there it is, sorry, h k, okay? So our vertex actually tells us where our vertex will be. So if I were to look over at this parabola that I have graphed over here, this is just a general quadratic. There's no specific rhyme or reason to it. We know our a would be positive because it faces upwards, right? It's opening up. But our vertex, our x-intercepts would be here. There would be our y-intercept. We learned about those the other day. And our vertex is where the parabola changes direction, which is down here at the bottom. So your vertex would be right here. And it would be represented by whatever is hk. All right? And we'll look at some examples here in a second. All right? So your vertex form simply tells you what that point is. All right, so, yeah. Identify the vertex of the following quadratic function. So it says we remind ourselves what our vertex form is in the vertex. So these are really simple. Your vertex here, notice your x-coordinate of your vertex is h, and your y-coordinate is k. And in this case, I have 2 here and a 1 here. Now notice that is a -2, but this is a minus. It's always the opposite, okay? So it's going to be +2, +1. It is that easy. I'm actually going to put that in a different color for your notes so you can tell that it's the solution. And so down below, since we have an x plus 10, we need to get the opposite of +10, which is -10. And then your y-coordinate is still just going to be 3. Very, very straightforward there. Now let's work the other way. Write a quadratic equation with a vertex at the following point. So for number 1, we have a vertex at 7, 3. Now, something important to point out, we have not mentioned an a yet. In this case, I want you to assume a is going to be 1. You'll get more of that in Algebra 2 and when we do transformations, but for now, don't worry about the a. Just worry about identifying your vertex. So it's going to be f of x equals, let's see, I have, once again, another color, sorry. So we have f of x equals x. Let's see, my h here is 7 and my k is 3. So it's going to be x minus 7 to the second power plus 3. So your k, notice your y-coordinate always stays the same, but your x-coordinate is always opposite. So down here, let's see, you have hk. So it's just going to be f of x. So it's -3, so it's going to become +3 to the second power minus 6. And then the final one here at 0, 0. Huh, that is interesting. Well, that would look something like this. F of x equals x minus 0 squared plus 0. But if I have 0 and 0, I can just write that as f of x equals x to the second power. All right, guys, so in the next video, what we'll do is we'll convert from standard form to vertex form. See you then.